Hello everyone. In this video, we are going to discuss the second problem which came in B.Stat B.Math 2019. So here's the problem which says that f is a function from 0 to infinity to r, and it's defined as f of x equals to limit n tends to infinity cos to the power n 1 by n to the power x. Now we have to show that there is exactly one point of discontinuity, and we have to evaluate the value of the function f at the point of discontinuity. So let's do it. So these are the informations that have been given to us. So now notice one thing, that x is greater than 0. So let's take advantage of that. So this implies that 1 by n to the power x tends to 0 as n tends to infinity. And so now let's take log on both the sides of this function. So ln f of x will be equals to limit n tends to infinity n ln cos 1 by n to the power x, or else I can write f of x is equals to limit n tends to infinity exponential n ln cos 1 by n to the power x. Okay, so this exp means e to the power this thing. Okay, so now I have a claim, that is limit t tends to 0 ln cos t by t square, this becomes equals to negative half. So let's see if my claim is true or not. So limit t tends to 0 ln cos t by t square is equals to limit t tends to 0. Now I'm using the L'Hopital's rule. So you can see that the L'Hopital's rule is valid here. So differentiating the numerator and the denominator, I get this. And this is nothing but a negative 1 by 2 limit t tends to 0 sine t by t. And you know that this is nothing but sine t by t goes to 1 as t tends to 0. And we get negative half. And so if we apply this in our problem, then ln cos 1 by n to the power x by 1 by n to the power 2x. So this is what we should take, right? Because we have this t, and so we are taking t square in the denominator, and this should be equals to n to the power 2x ln cos 1 by n to the power x, and which tends towards negative half as n tends to infinity. Okay, so here I just use the claim that I proved. So now f of x is equals to limit n tends to infinity e exponential n ln cos 1 by n to the power x. So I need to apply my claim, and for that I have to adjust the power of n. So this is coming out to be exponential. I'm taking the limit inside. N to the power 1 minus 2x times n to the power 2x ln cos 1 by n to the power x, and this you can write it as negative 1 over 2 limit, because this limit we know, and so we just are dependent on the limit of n to the power 1 minus 2x. So now let's check what's the limit of this thing is. So limit n tends to infinity, n to the power 1 minus 2x is equals to, now there are three conditions. When x is greater than half, so then you can see that this thing goes to 0. Okay, and when x is equals to half, it's pretty easy to see that this thing goes to 1. And when x is greater than 0 and lesser than half, then this goes to infinity. So here we restricted x till 0 because our domain is from 0 to infinity. And now let's evaluate our main function limit. So that will be, there will be also three cases. So when x is less than half, so you can see that this goes to infinity, and so, and here you have a negative sign. So 1 by e to the power something infinity, so that thing will go to 0. And when x is equals to half, this is the very easiest one, so this goes to e to the power negative 1 over 2. And when x is strictly greater than half, so you have 0 here, and so x e to the power 0 is 1. Okay, so this is all the limits that we have for our function. So now you can easily see that the function has only one discontinuity, that is at x is equals to half, and also the value of the function at x equals to half is e to the power 1 negative 1 over 2. So the answer for part B is f of half, where the discontinuity occurs, and that is negative 1 over 2.